Hello and welcome to CodeByte. This is an introduction to sets, relations, and functions. Starting off with sets. In simple terms, a set is just a collection of anything. Whether it be numbers, regular polygons, or even penguins for that matter. This module though, we will be focusing on sets in mathematics. Sets in math are typically represented using curly braces. By mathematical definition, a set is a collection of distinct elements. Here are some examples. The comma-separated values enclosed within curly brackets are called elements. The cardinality of a set denotes the number of elements in a given set. It's represented by n of R. In this example, the cardinality of set R is 7. Now let us look at the concept of Venn diagrams. A Venn diagram is a way of representing sets in a pictorial format. A universal set, a set that contains everything, is shown using a rectangle. All the other sets are shown using circles. Subsets. A subset is a part of a set. For example, here the sets S1, S2 and S3 are the subsets of the set R. This is how a subset is represented in a Venn diagram. Let us move forward to the concept of union and intersection. Union. As the name suggests, a union is just a simple mixture of both the sets. Intersection. Here we just pick out the common elements from both the sets. For example, let us consider two sets, A and B. Set A contains elements 1, 2, 5 and 7, and set B contains elements 2, 7, 9 and 13. Then by simply combining all the elements from both the sets, the union of the two sets contains the elements 1, 2, 5, 7, 9 and 13, and the intersection of the two sets would result in the elements 2 and 7. General sets in math. Natural numbers. These include only countable numbers like 1, 2, 3 and so on. Whole numbers. When we add the idea of nothing to the set of natural numbers, we get whole numbers. Integers. Considering negative numbers along with the set of whole numbers gives us integers. Rational numbers. Any number that can be represented in the form of p by q, where p and q are both integers and q is not equal to 0. Real numbers. This set contains all the numbers that can be perceived in reality. Complex numbers. These are imaginary numbers that are used to solve complex equations in quantum physics. Moving forward to relations. To understand what a relation is, we must first understand the concept of Cartesian product. Let us consider two sets, A and B. Set A contains the elements A, B, C and D and set B contains the elements 1, 2, 3, and 4. Then the Cartesian product includes all ordered pairs x, y, where x belongs to set A and y belongs to set B. It is also known as the cross product. A relation is nothing but a simple subset of this Cartesian product. This subset is chosen according to some condition or logic. Functions. A function, in very simple terms, takes some input and produces an output. It is expressed as f of x. Let us look at an example of evaluating a function for a given set of values. Here f of x is equal to x squared. For x equal to -1, f of x becomes 1. For x equal to 2, f of x is 4. And for x equal to 5, f of x comes out to be 25. The set of all possible inputs is called the domain set, and the set of all possible outputs is called the range set. Visualizing functions using graphs. The x-axis shows all the inputs and the y-axis shows the corresponding outputs. Let us consider the previous example where f of x was equal to x squared. Here the domain set is the set of all real numbers. Let us plot out a few points on the graph. This graph infinitely extends over all real values of x. That's it for this video. Thanks for watching and stay tuned for our upcoming videos. Follow us on our socials and check out our website for more details. Stay curious and keep learning.